My name is Paige Graff, and I want to welcome all of you to tonight's Pathways to Careers in NASA Science and Engineering webinar event. We've got registrants from across 29 states, Canada and India. We've also got participants from Puerto Rico, and there are others that perhaps are not represented on this map. So we welcome all of you, and we're so glad to have you joining us today to hear about the career pathways of Christopher Snead, Farnaz Mazhari, and Kristen John. Again, we encourage you to participate in Slido. And before I turn things over to Christopher, I also again want to make sure to thank the SEAS program at UT Austin for hosting this event. Selena Miller and Margaret Baggio, we very much appreciate you for allowing us to share our career pathways for our experts tonight. So with that, I am going to stop sharing and I'm going to turn things over to Christopher. Welcome, Christopher, and so glad you're with us.
My name is Christopher Snead. I am the Hayabusa 2 sample curator at NASA Johnson Space Center, and I'm going to talk about the path that led me to this place right now. So my background was kind of meandering. In high school, I was very interested in astronomy and space. I would spend a lot of my free time in the library reading astronomy magazines. I was especially fascinated at the time about the Keck telescope, which was at the time the largest telescope in the world. And so this was really something that was captivating, but I didn't really have the confidence or think I was capable of pursuing a career in astronomy or space sciences. So when it came time to apply to colleges, my intention was maybe to go into medicine, and I applied in that way and was accepted to UC Berkeley in their bioengineering program. So I started Berkeley as an engineering major, and that really was not a good fit. I did not do well. My grades were pretty low. And after 3 semesters, I withdrew from Berkeley and moved back down to Los Angeles with my parents, where I worked in an office doing sort of clerical work. But you know, in my spare time, I was still always very interested in astronomy. I had a small telescope, and I would use that to study the constellations, look at the planets at night, and observe some of the brighter deep sky objects from the backyard or the mountains to the north of Los Angeles. So I did that for about 2 years. And after talking with some very supportive advisors at Berkeley, I decided that I would go back to Berkeley and switch from engineering to the physics department so that I could pursue astronomy. I had a lot of prerequisites to fulfill. And so I moved back to the San Francisco Bay Area, and I spent 3 semesters at a community college where I took some of those courses before transferring back to Berkeley as a physics major. One of the things about going to a school like UC Berkeley is you can learn physics and the course background pretty much at any good college that you go to. But at a place like Berkeley, the real opportunity comes from doing research, especially over the summer. And so I was awarded a research scholarship to conduct summer research. And I started working in an experimental astrophysics lab led by Dr. Andrew Westfall at UC Berkeley Space Science Laboratory. And my summer internship project involved working with this exotic material called aerogel. And spoiler alert, this sort of changed the entire direction of my career and led me to where I am today. So let me give you a little background. Around the time that I started working at Space Sciences Laboratory, there was a mission flown by NASA called Stardust. And it was launched in 1999. And its goal was to fly through the tail of a comet and capture comet dust and return it back to Earth. And this is the first time in history this would have been done. The way it captured samples was, instead of landing on the comet, it would fly through the tail at what we consider a fairly low velocity. It was 6 kilometers a second, so it was still much faster than a bullet. But the particles of dust would embed themselves in this foam-like glass material called aerogel, and it would leave these impact craters like you can see right here. So my summer research project was, okay, great. If you have these particles in the aerogel, how do you get them out? And this is not really a trivial matter. So I spent some time at the Space Sciences Laboratory learning, first of all, how to work with aerogel, how to cut it. It doesn't cut very well. I like to describe it as trying to cut styrofoam with a dull butter knife. It tears more than it cuts. So we developed some techniques not only to cut the aerogel, but to remove the entire impact feature. You can see here is this carrot-shaped impact feature. And the reason why that's important is there's material all along the impact feature that scientists want to analyze. And so this was my research project for about that summer. And then the following 5 years, I graduated from Berkeley and went to work full-time at Space Sciences Laboratory. And this culminated in the return of the Stardust mission in 2006, where I collaborated with scientists and curators at Johnson Space Center, and we installed the system that we use to extract aerogel at Johnson Space Center, and that's still in use today. And so here again is another one of these features, and here is this carrot-shaped track that we're pulling out and removing the particle and all the material out of the bulb. So this was a very exciting multi-year project that culminated in the successful return of comet samples for the first time. So after I did that, I went to graduate school at UCLA, where I wanted to study some of the results of the Stardust mission. There are a number of ways that you can study extraterrestrial materials. And the reason why we like to study them is they, like many of Earth rocks, record information about the environments in which they formed. So in a way, they're like fossilized thermometers and fossilized pressure gauges. And you can learn a lot about the environment by studying these rocks. And one of these sort of fingerprints that I was a specialist in graduate school was studying what we call the oxygen isotopes. These tell you a lot about some of the formation processes in the early solar system. And people had been studying these in meteorites for years, but no one had ever looked at the oxygen isotopes of a comet particle because we had just received comet particles. So my big graduate student project was, what is the oxygen isotope composition of comet dust? The challenge with this analysis is that aerogel is made mostly of oxygen. So you want to measure oxygen in a thing that was captured in mostly oxygen. That was a hard thing to do. So what we ended up doing was looking at the little impact craters that surround the aerogel in these foils. And if you look under a scanning electron microscope, these are what these impacts look like. And they leave residues of the material that hit them. So that was my big graduate student project. My dissertation was basically the results of this measurement. And a lot of the time I spent was figuring out how to make the measurement. The instrument that we use, they like to have samples that are flat, and impact craters aren't flat. So I spent a lot of years trying to figure out how to flatten these craters and mount them into a mass spectrometer so that I can get the results of the compositions. So practically, this is what graduate school looked like for me. This is a secondary ion mass spectrometer. Here's me looking at some screens, and you just spend late nights gathering data, trying to understand what the results are of these oxygen isotope compositions. And it doesn't look particularly exciting, but the results that you get are things that no one's ever seen before. And also in graduate school, you get to do other fun things. So here I am in the desert in California going meteorite hunting. You can just actually go out to a dry lake bed, and if you know what you're looking for, you can find meteorites. And I also collaborated with an astronomer and got to actually go on an observing run at the Keck telescope. So this was a childhood dream of mine that came true. I actually got to use these telescopes that I read about in magazines as a child, or as in high school. So when I graduated from graduate school, I got a job at Johnson Space Center, and my specialty was trying to understand how to handle really small particles. These are particles that are smaller than 100 microns. Think about your human hair, the size of your hair. That's about 100 microns. And this is important because a lot of the missions that we're planning for sample return are going to have a large quantity of really small particles. And so it's really important to reliably handle those kinds of samples. Microparticle curation, really what it is you've collected your samples and you need to move it from how you collected it, this collection substrate. In the case of stardust, that was aerogel. There are other collection substrates, and you need to move that to something that you're going to analyze it on, or you need to store it for future use. And the goal is when you're moving those particles from point A to point B, you want to minimize the loss of sample during those transfer operations. And so how are particles lost during transfer operations? Well, if you think about things that are macroscopic, like the size of a rock, usually gravity is the main force that you're working with. You know, you pick something up, you let it go, it falls. Much smaller than a millimeter, and then there are other forces that become more relevant than gravity. So one of those forces is called the van der Waals force. There are these sticky intermolecular forces. I like to say at that level, imagine everything is coated in a fine layer of Post-it note glue. And so particles will stick to your tools by just handling them. And that's a very convenient way to manipulate things. But then there's also something called triboelectric charging. This is the kind of static charge that builds up when you're walking on a carpet. And this will cause your particles to react somewhat unpredictably. So I have a small video here. Here's a glass needle, and I'm trying to pick up a particle that's 20 microns. And you see the needle's coming down. I've used the van der Waals forces to successfully pick up the particle, but you notice it's dancing around on that needle, and now I'm moving it, and boom, it just charged up and it's gone, and now that particle's lost. So the whole goal of small particle advanced curation is avoiding that scenario. So I did that for a while, but also something that's very exciting is that in December of 2020, JAXA, which is the Japanese equivalent of NASA, they returned a sample of a carbonaceous asteroid from the asteroid Ryugu, and they brought back 5 grams. And after a year, we have an agreement with JAXA that we exchange samples. So in December 2021, which was a year after that, they delivered 10% of their samples, or 500 milligrams of asteroid regolith, to Johnson Space Center. And so this has been a really great arrangement for us and for them. In exchange for the 10% of the samples that they gave us, we will provide them with some percentage of the samples that we are expecting to get back from the asteroid Bennu, returned by NASA's OSIRIS-REx mission, which is going to come back in September of this year. And so now I have transitioned to become the Hayabusa 2 curator. That happened in April. And right now, the big task we're doing is to build a catalog of the samples that JAXA provided us, learn how to subdivide them and ship them out to investigators so they can do the kinds of interesting science that I described earlier. And then finally, coming soon, as I mentioned before, is OSIRIS-REx. This is NASA's sample return mission. It will bring back several hundred grams of asteroid regolith from another carbonaceous asteroid called Bennu, and that will happen in September. And my involvement in that mission is that I'm developing methods to remove samples from the Velcro collectors that touch the very top surface of the asteroid. And these particles will be extracted and handled in chemically inert nitrogen sample cabinets, glove boxes. So this is a real challenge that we're learning to work with right now. And so that is what I do in a nutshell and how I got there. And I will turn it over now to Farnaz.
My name is Farnaz Mazhari. I am a microbiologist in the Astromaterials clean rooms at NASA Johnson Space Center. Okay, so I actually went to UHCL for both my bachelor's and my master's degree. I have a degree in biology. My bachelor's degree is in biology, and my master's degree is in biotechnology with a specialization in bioinformatics. My first 2 years of college was pretty rough. I didn't know what I wanted to do. I was just kind of listening to people around me, my family. I'm Persian, so in Middle Eastern culture, everyone is mostly a doctor, an engineer, lawyer, one of those three. And so I was like, okay, I guess I'll do med school. Sort of similar to Christopher, I guess. But I shortly realized that that wasn't going to work for me. My grades were not that well, and it was mostly because I wasn't passionate about what I was doing. I was also a bit depressed, and yeah, so the first 2 years was basically like trial and error, depression, not doing great in my classes because I didn't know what I want. And then at some point, I decided, you know what? I like research. Ever since I was a kid, I was extremely curious. I loved all kinds of things. I loved history. I loved philosophy. And so I was like, you know, I actually want to make a difference in the world. So I decided I am going to take the path less taken. Yeah, I decided I had nothing to lose. So I am going to try and do research. And my first step was finding a way to get into that. I didn't really know how to reach out to professors and all of that. And then when I took microbiology, I had heard that he is really, my professor in microbiology was really involved in research, and he likes doing research projects with students. So I was like, okay, this is my opportunity. And he had told us that, yeah, you guys are all going to do your own projects. You're going to come up with it, all of that. And I did that. I took it very seriously, and I went and I researched what it was I wanted to do. And I remember I went up to him after class and I was like, I have an idea. It's called the checkerboard assay. And he was like, okay. And so we actually walked to the library together, and he looked up some literature and he printed it out for me. And that's where it all started. And so actually right here, you can see that is actually the checkerboard assay. So what it did was it looked at the interactions of essential oils and antibiotics against E. coli. And we actually found that most essential oils, especially cinnamon, acted synergistically with antibiotics when put together, meaning they are more effective at killing bacteria, E. coli in particular, than separately. And so for an undergrad, for someone who had never done research before, I look back and I think that was a pretty profound project. I think I did pretty well. And so yeah, from there, something lit up inside of me, really. I found my passion. It almost cured my depression. I was in the lab every day. I lived there, and my lab partner helped a lot too. We were just like the dream team, always in the lab, always doing our research, doing independent studies, taking more research classes, more microbiology classes. And I don't know, I just really thought back then I was going to change the world. I just had that thought in my head. And yeah, a lot of things just came along my path. A lot of doors just kind of opened themselves. So yeah, about 2 years in, I was once again not in a great place in my life. I was broke. Wasn't I wasn't doing too well in my personal life. Um, and so I was looking for jobs, and I didn't have much luck because I still hadn't graduated yet. I still had another semester. And then I happened upon a microbiologist internship for Jacobs. Jacobs is a contractor for NASA, which is who I work for right now. And I was like, oh, cool, microbiology, that's right up my alley. And I applied for it and actually didn't know it was NASA. Um, until the interview. They were like, yeah, we're here at NASA Johnson Space Center. And I was like, what? That's so cool. Um, and I didn't think I'd be able to get it, but somehow I did. And, I attribute that to the fact that I was just really passionate about what I did, and I think that showed. Um, but it's funny because, in the beginning, I thought I'd never be able to get a NASA internship or something like that because I wasn't a perfect student. I didn't have perfect grades and all of that, like I thought most NASA interns do, right? I thought, they're all going to like really good schools and have really perfect grades and this and that. And I was able to get this internship. And so let's see. Yeah. And then that was the start of my journey at NASA. I started interning in the geomicrobiology lab, doing microbial monitoring for the Astromaterials curation clean rooms. So those clean rooms hold all sorts of samples from different space exploration missions, as we already talked about. And so like this is a little fungi that we isolated. Basically, we go in and we swab different areas, and then we plate them and culture them and sequence them and do all sorts of stuff to identify them and look for trends in the clean rooms. And this is really important because, well, bacteria and fungi have a lot of ways that they could perhaps harm these astromaterials. And we don't want that because, so where was I? Yeah, so these little microbes can potentially harm astromaterials, and that could affect a lot of really important research, right? Particularly for astrobiology. If we're looking for life on other planets, this and that, we need to know the difference between life on Earth and life elsewhere. And it's hard for us to know that if like these little critters are contaminating everything, and they could also, eat the rocks and all of that. So it's definitely very important work. Most people don't know that there are microbiology opportunities at NASA. A lot of people were surprised when I told them. They were like, oh, well, I thought NASA was mostly like engineers and like physicists. And I was like, no, we exist too. And, we're steadily growing. And so we actually collaborate with the microbiology lab at NASA. Our lab is nearby and we use their facilities a lot. And they analyze samples from the International Space Station. So that's really cool. So yeah, for people who are looking for biology opportunities, astrobiology, astrogeology, all of that, there's plenty of different biology careers that you can pursue at all the different NASA centers. And so yeah, eventually I did my master's thesis in collaboration with my team at NASA. I was really, really thankful, really grateful that they agreed for me to do this. And it was very, very, very difficult though. Yeah. This is my little graduation cap. So I did genomics. So I looked at the genomes of a sample set of bacteria that we collected from the clean rooms. And basically that involves sequencing the DNA of the entire DNA of an organism. And usually we don't do that. We only use like one gene, which is the 16S gene, mostly because it's difficult and expensive to do it the genomic route. But when you do genomics, you can find out a lot of information. And that's really where we're trying to go with microbial monitoring, especially with these, when dealing with these precious samples in these Astromaterials clean rooms. So yeah, I did that. To be honest, I had no idea what I was getting myself into. Someone gave me the idea. They're like, yeah, you could do genomics, then you could sequence the genomes. And I also did MALDI-TOF, which is a sort of mass spectrometry. And I compared the two. I looked at, so it was kind of like a double whammy, right? Like I did both genomics, which is notoriously very difficult. And then I also did MALDI-TOF, and I compared the two. And yeah, I didn't think it was going to be this difficult, as difficult as it was for me. But evidently it was. And I had two choices: either quit or force myself to level up a lot and sort of suffer. And I, chose the latter, which was to level up. I had no choice. But I'm grateful for it. It wasn't easy, but it made me a much better scientist. And I'm actually still an early career scientist right now. So there's a lot ahead of me. I have a long future ahead of me. I'm still considering a PhD, perhaps another collaborative effort in the same regard, if I can find an opportunity to do so. Most likely a career in genomics. I think genomics is beautiful. And I think, we're in like the age of big data, age of technology, and things are getting easier, technology-wise, cheaper. We're able to get more data faster. And it's a great time to be alive in the field of medicine and biology and space biology and all of that. And I'm really interested in biosignatures, astrobiology. I really want to help possibly discover life on other planets or that sort of thing, or understand life more in a deeper regard. And so advice I would give truly and honestly is to pursue what you're passionate about. I know that's cliche, but it's so true. It's really hard to get through all the setbacks if you're not passionate about what you do and you don't believe in yourself and you don't believe in what you're doing, because there's going to be a lot of failures. There's going to be a lot of setbacks. There's going to be a lot of people who get on your nerves, this and that. And so, you really have to be grounded and, know what it is that you want and love what you do. With that, I will pass it on to Kristen.
So thank you guys for joining today. I'm really excited to have the chance to talk to you all about my path to NASA. This is a good time for me to
Kristen, I hate to interrupt, but if you want to just get rid of that little thing on the bottom and hide that so that doesn't take over your slides. Thank you.
Yes,
sorry.
Definitely. No, that's great. This is a good time for me to be talking about my path to NASA because I'm right now working on a application to a leadership program, what they call a mid-level, mid-career leadership program. And so I'm kind of having to assess my career and what I want next. And so it's kind of fun to be talking to you all about this as I'm answering questions on what my future will look like. So a little bit about myself. I grew up in Dubai mostly and in Houston as a child. And so I think that definitely shaped a little bit of who I am and how I was raised. So there's a picture of me on a camel back in the day. I lived in Dubai when people didn't know what where Dubai was or what it was. It wasn't as popular as it is now. And when I was 10 years old, we moved to Houston. And so here's some pictures of me around that time. I put here, I loved space, I loved science, I loved my sisters. You can see the picture there. And apparently I like dressing up. The picture in the bottom I show, because we were overseas for so long, we had the chance to travel a lot. And so I think that was a big influence on me as a kid. I saw a lot of the world. And so that instilled the travel bug in me. And I had learned a lot just about other cultures and other places. And also, living abroad and moving made me really close with my sisters. And so my sisters were a big influence. One of the reasons I bring that up too is when I look at my sisters now, who are my best friends, how different our paths are. And in some ways, when I look back on some of the decisions I made as a kid, as far as what my interests were, I think a lot of it was, well, my sisters are doing this, so I want to do something else, and trying to be different than them. And so I became kind of the science one, the one who liked science and math and space and that sort of thing. And that kind of became my thing at a young age. So you can see a picture there of me dressed up as Sally K. Ride. When we moved from Dubai to Houston, I remember thinking it was like the coolest thing ever, because Houston was known for, at that time, the Houston Rockets, the back-to-back repeat champions of the Houston Rockets. So I was excited because I like basketball. And then, of course, I was excited because Houston was Space City. And so I think I already had that kind of love for space. Of course, like half the people at NASA, I had wanted to grow up to be an astronaut one day. And then moving to Houston just made me even more excited about that. And so just kind of looking back at my childhood and, thinking through all this, what were some of the pivotal moments in my childhood? One was moving to Houston, right? It was the coming to the Space City, kind of a new start. And, at kind of the right age where I was starting to, pick the subjects that were my favorite, that sort of thing. Another pivotal moment for me was actually in 8th grade. Some students came to our junior high and basically said, hey, there's this science academy. It was called the Academy of Science and Technology. And I would basically have to leave the friends that I was with and go to a new high school across town to do this academy. And you had to apply for it. And I just applied. I didn't even tell my parents until it got to the point where, they had to fill out some forms or something. And so it was all on my own, right? And it was me choosing to make a pretty big decision as an 8th grader to say, I'm going to leave my high school and go somewhere else. And so that was a big deal for me. And then I was surrounded by other, I'll joke that I went to, the school for nerds, right? It was other people that were interested in science and math, and other people that were good at science and math. And I think what was really interesting for me at this stage in my life too, is that I think I went from being, one of the students who was probably better at science and math in my classes to surrounded by people who were really, really smart. So I put a picture there of a couple of my friends. Every one of those was, national merit scholars and, went to Ivy League schools and these were the people I was surrounded with. And so there were certainly times where I was intimidated or, I definitely was not the smartest person in the room. Right. And so, but I think that was pivotal for me because I learned a lot by not being the smartest person in the room, by being with people who were a lot smarter than me, and had some great opportunities there. And I think that experience in high school gave me the confidence to think that, hey, I could pursue a career or a major, at least in, science or math or something like that. And so another pivotal moment I'll get to is picking my college and picking my college major. So picking my college, so I was, now Houston was home for me. And one of my sisters went to University of Texas at Austin, which was just a couple hours from home. And I was scared. I didn't want to go too far away. A lot of my friends were going to, far off schools, and I wanted what was comfortable. And for me, it was, going where my sister went. Luckily, I was able to get into that school, and I went where my sister went. I didn't look back. It was definitely low stress for me. And looking back, that was a great decision because I didn't exactly know what I wanted when I was, 17 and applying to colleges. And I'm glad I ended up where I did. And then picking my major. So at this point, I've gone through, middle school, junior high, high school, being good at math, right? Good at math, good at science, like a lot of future engineers and scientists are. And so I thought, okay, I'm good at math. I'll pick math as my major. And so before I went to college, math was supposed to be my major. And literally a couple of weeks before, I started getting nervous, and I thought, oh, like what, do I really want to like keep studying math? What do I really want to do? And I had this moment where I'm like, I don't know if that's really what I want my major to be. And so I actually went onto the University of Texas website and started looking at the list of majors. And I started, they had some sort of list, and it was in alphabetical order. And so pretty quickly I got to aerospace engineering, and I thought, aerospace engineering, I've always wanted to, I've always liked space. I always wanted to be an astronaut. And, at this point in my life, I wasn't thinking about that. I wasn't thinking I want to grow up and be an astronaut, but I was thinking, gosh, I want to, what am I really passionate about? Like Farnaz talked about, like, what was I really passionate about? And I thought, well, this sounds really cool. And I read the like 1 or 2 sentence description of aerospace engineering, and I thought, this sounds cool. Made a couple phone calls to the university, and somehow I was able to switch majors like a week or 2 before college. And then I got to college and immediately knew I was in the right place. And so I am thankful for that decision I made, and the folks that let me switch at the last minute. So then, I got to college. I went to UT in Austin, and there were a couple, and I had a great time there. I was there for 4.5 years. I did the co-op program. I did internships. I did lots of research to get involved in putting this presentation together. I was trying to find some fun pictures to share, but I couldn't find any. So here's the Hookem logo. But there were a couple, what I'll say, pivotal moments in college that I think were key. The first thing I did is I took this Intro to Aerospace Engineering course in my first semester, and I was enamored by the professor. I thought he was the coolest thing ever. His name was Dr. Hans Mark. If anyone Googles Hans Mark later, he was really amazing. And he just really inspired me. And he always wore this lanyard for this lab that he worked at, and he talked about it a couple times. And so at the very end of the semester, I went up to him and I said, I would like to work for you. Is there anything I can do to work for you? And he said, I don't, it's about to be the, winter break, come back to me in the new year and ask me. So I did that. I went back in the new year. I asked him, and he said, well, we don't really have any openings in our lab right now, but go talk to my secretary and we'll figure something out. And so I was very persistent, and they let me work for him. So I started by, doing really like simple jobs, working on his lectures and taking some of his lectures and typing them up, and then turning his handwritten graphics into computer drawn graphics, and then eventually led to a position where I could actually work in the lab as an undergraduate research assistant. And anyway, it started a relationship with this professor that lasted up until he passed away just a year ago. And so it was really a great opportunity, and I wouldn't have gotten that if I didn't ask, and then I wasn't persistent about going back and asking for that opportunity. And then internships as well. There was an internship at NASA Ames Research Center that I wanted to do. And so I asked a professor who I hardly knew, he was just my teacher really, if he could recommend me for this internship, and he did, and I got it. And same with getting involved. I saw a picture of students floating around in microgravity on the Vomit Comet, and I saw that, and I asked, how do I do this? And I got in touch with the right people, and I was a freshman at the time, got in touch with seniors, and we formed a team to do a microgravity experiment. And so that was my big thing for those of you that are in college or that are going to college soon, is just ask whatever you're interested in. No one is going to come up to you in a group of dozens or hundreds and say, hey, you want to do this? You have to be proactive. So be proactive, ask to get involved, ask to work for that professor, whatever it is. And I will say, my transition after undergrad was grad school, which I'll talk about next. And one thing that almost everyone had in common in at least my grad program was undergraduate research experience. So if you do think research is in your future or grad school is in your future, I think getting opportunities for undergraduate research is critical. Okay, so here's a little bit of a timeline of kind of, if we just step back and look at my education and kind of my roles at NASA. So, when I picked aerospace engineering, it's like I said, because I love the idea of space. And I became quickly passionate about aerospace engineering, and of course, started that thinking, I would love to work at NASA one day. So I got my BS in aerospace engineering, and then I went on to grad school. I knew from my internships in undergrad that I wanted to get a PhD, just from kind of who I as I was in my internship, seeing what people were doing, I thought it was the people with the PhDs that could do the neat stuff, the research, right? And so I had kind of made that decision pretty early on. It worked out well for me because about the time I graduated is when there was a recession, and so a lot of my friends that did go into industry struggled a little bit because it wasn't a great time to be in the working world. But I ended up staying in school all the way through, and I got my master's and PhD from Caltech. And then, soon after that, I joined NASA, and I've been here ever since in different capacities. I started as part of the postdoc program, which is something you do right after your PhD. And I was really in a science organization there and for 3 years. And then I transitioned to Jacobs, working as a contractor, again in the science organization. And then in 2020, literally a month before the pandemic, I joined JSC Engineering. I should note that my time here in the science organization, I was an engineer, one of the few engineers working in the science organization that both Christopher and Farnaz represent. And so, felt sometimes like a fish out of water, but also I recognize now the great opportunities I had by being one of the few engineers in this organization. And most recently, I'm focused more I'm still in JC Engineering, but I'm on a detail to NASA's Space Technology Mission Directorate, working on dust mitigation. But what I really want to kind of focus on this timeline is, this is kind of easy to put these things on a timeline and make it look like, okay, cool, I went to school and then got my job at NASA and I've had all these different positions. But there were really pivotal moments along the way that I think led me from each step to the next step. And so when I knew I wanted to do grad school, and I didn't have a perfect GPA. And I had, and still do, the imposter syndrome that I'm sure several of you have experienced. And if you don't know what the imposter syndrome is, good for you. I applied to 14 grad schools because I was sure I would get into none of them. I ended up getting into, I think, like 12 of the 14. Not saying that to brag, but just saying that, there's always been this thing following me, like, oh, I'm not capable, or I'm, someone's gonna figure me out and figure out that I'm not meant to be here, that I was, let in here or there or somewhere by accident, right? And so getting into those grad schools was definitely, reaffirming. And so then I went to Caltech. It wasn't easy. It was hard. The master's degree was a 9-month program. It was the toughest 9 months of my life. And once that finishes, then I moved over to the PhD program. And if you get your PhD, one of the things you have to do is a qualifying exam, which is really intimidating. You're standing in front of professors, in front of a chalkboard, answering questions on the fly. And I had to take mine twice. I failed we had 3 exams and I failed one of them and had to take it twice. And that was a really hard time in my life, a stressful time, knowing that, I had to pass this exam to stay in the program. That was tough. And then another key moment for me was towards the end of my PhD. Someone named Paul Abel, who's from the Astromaterials group that you've heard about, came to Caltech. And I think he had a presentation that he gave at like 8 a.m., which now, that looking back, I realized that was really early for Paul and really early for me to get up and as a college student and show up for an 8 a.m. talk. But I thought, wow, this guy's coming from NASA. And at this point in my research, I was in the PhD program, and even though it was aerospace engineering, it was so far removed from space applications. It was much more fundamental research. And I knew, hey, why did I get into this in the first place? It was to work at NASA one day. So this guy came to Caltech to talk about Phobos and Deimos, the moons of Mars, and I was immediately fascinated, and I knew nothing about asteroids at the time, nothing. But I went up to him afterwards and I said, that was really awesome. I would love to work for you. How can I work for you? And he gave me his business card and said, message me. And so, of course, I messaged him. And then soon after that, there was a government shutdown, and eventually he kind of reached back out to me, and we actually started this back and forth where he realized, oh, wow, like, you're not the typical person that's in our organization, but I think you'd actually be a really good fit. And he saw something in me. And so that kind of started my attempt to get to NASA. So I now had what I thought was my foot in the door. But getting into the NASA postdoc program wasn't easy. It's very competitive. It took me 3 times to apply to get in. And so even though I had someone in at NASA who wanted me to work there, he can't just, snap his fingers and make it happen, right? So I actually had to apply 3 times to get into the program, to finally get my foot in the door at NASA. So I just wanted to highlight a couple of those things to say, keep trying. I know even the internships at NASA are extremely competitive. There's lots of different avenues to get internships at NASA. There's lots of every single path to NASA looks different. So, just keep trying and ask, right? So, and then another, of course, I guess I'll call setback was COVID, right? That affected all of us in different ways. I'm here sitting at a coffee shop talking to you guys because COVID has enabled that, right? There's definitely some perks of telework and doing things remotely. And now we're finally starting to get back into the office more and travel a little bit more. But the last couple of years have looked really different. And that was right as I was starting in JC Engineering. I was literally there for a month before COVID hit. And so that was really challenging because I didn't know people. Everyone I knew was over in the science organization, and now I'm in a new organization working from home. And so I had to build relationships, through teams. So, and then I want to talk a little bit about my career so far, just at a very high level. If I had to summarize it in 4 bullets. First is that I've sent experiments to space. I had the opportunity as an engineer in a science organization to lead several projects to send experiments to the International Space Station. That was awesome. I learned so much about flight hardware, about teams, about leadership, about failure, about budget, about timelines, everything. I studied asteroids, so my kind of expertise was really from the experiments that I did studying asteroid material, the surface of materials, and that led to what I do now, which is managing the lunar dust. So the moon is covered with dust, and so some of those forces that Christopher was talking about, those cause issues for dealing with hardware once it gets to the moon. And so that's my job, is to make sure that when we get to the moon, the dust doesn't mess up the hardware, basically. And so I actually had 0 lunar experience when I started this role. I actually was the asteroid regolith person who happened to be in the right place at the right time. And someone needed someone who understood something about dust. And compared to Christopher and others, I didn't know much, but I knew enough and had the passion to get in there and learn a lot. And I will say what I'm doing now and what I've done almost my whole career at NASA looks nothing like what I studied for my PhD. And then science and engineering, really that intersection of science and engineering has been huge in my career. Like I said, I was an engineer in a science organization, and now I'm in an engineering organization. I have my PhD, so some people might call me a scientist, depending on who you ask. And so sometimes I can say, oh, I'm a scientist, or I'm an engineer. I can use it to my advantage. But being able to communicate between scientists and engineers has been key. And now I work a lot with technology development. And so really having that understanding of what scientists need and what scientists are trying to do and how the engineers can build it is critical. Me now. So this is kind of me now. I'm a working mom of 4. My job title is Technical Integration Manager for Lunar Dust Mitigation. So for all intents and purposes, I'm leading the agency for dust mitigation efforts for going back to the moon. And I've got a huge team of subject matter experts that help me. And my biggest challenge of all is balancing it all. And we don't balance it, right? There is no balance, but it's, trying to figure out which priority it matters the most at the moment. And so it's a lot, but I love it. No 2 days are the same, whether I'm at home with my kids or working. Seriously, no 2 days look the same, and that's a lot of fun. And just a tiny bit about dust mitigation. This is kind of a fun graphic that we had put together. Again, Christopher talked about some of the challenges of working with fine particles. The lunar dust is, it's insidious is a word that's been used to describe it. It gets everywhere. It has implications for solar panels, for gears, for crew health. It'll, upset your optics. We learned a lot from Apollo. And so it's a huge technical challenge as we go to the moon. It's not like your ordinary household dust. It's angular and it sticks to surfaces through some of those forces that he talked about. And the ways in which you remove it or mitigate it, there's lots of different ways you can do it. I know one of the questions in the Slido was about how students can get involved. Dust mitigation is a great way. We do a lot of crowdsources and challenges. And so if you're interested in finding a way to get involved, dust mitigation is a great way to find ways to come up with solutions or do some sort of design challenge. It's a really fun problem to solve, and it's a problem that's not going away anytime soon. So a couple takeaways. If you take away anything from what I've said, is one is just ask. If you want something, you have to ask for it. You have to be proactive, whether it's your, an internship or your next opportunity to get involved at school or at work. Next is get involved. in my hobbies in college was really being involved in my major, doing extracurriculars related to my major. I learned so much more from the research projects, the design challenges, that type of work that I did than I did in my classes. So classes are important, but I think the other things that you do outside of the classroom are really where you learn what you like and what you don't like and what you want to do and what you want to be when you grow up. Try again, right? I've had my fair share of failures and setbacks, both in getting where I am and also in projects and teams that we've led here. We're always, working up against obstacles and challenges, but you just have to keep trying and persevere, and then surround yourself by smart people. So that's something I feel like I've done in my education and in my career. Right now, I do lead a team of subject matter experts, all of whom are way smarter than me when it comes to different aspects of the lunar dust. And I don't need to pretend to be the smartest person in the room. I just need to know who the smartest people are. So anyway, I hope that a couple of these stick with you, and hope that that you guys have enjoyed hearing from me and Farnaz and Christopher. And I guess I went back to Paige to see what happens next.
Absolutely. Thank you so much, Kristen. And what we do want to do, and first of all, I want to thank each of our speakers, because you can see from the 3 different individuals that shared their career pathways with you tonight that every one of them is different. Each person is their own individual with their own style, their own pathway, but you might have found interesting similarities, including the whole idea of it not being a straight line, but how often these pathways do meander. And so we've had a number of folks participating in Slido and adding in input into the word clouds, and those are really great ways to also even remember certain aspects from each of our speakers. So thank you for your participation in all of that, and the Q&A area as well. And we'll have another poll that's open for some feedback on the event tonight. But in our last 15 minutes or so, we want to be able to look at, are there questions that we still want to have asked? So you can still put in questions in Slido, or some things that we want to reinforce. And one thing that I just wanted to mention, when Christopher was talking about aerogel, I actually, and I'm not sure if I can put this in the right light, maybe you can see, let's see if I can turn off a light and make this a little bit more visible on my screen itself. So I'm in this little box in my hand that perhaps you can see. That's actually a piece, oh, that's way too close, a piece of that aerogel. This did not fly, but this is that material that Christopher was talking about that captured particles from a comet. And what's so interesting about this is it is almost 99% air, yet I could put a Bunsen burner underneath this and put a leaf on top, and that leaf would not burn. So this amazing material that Christopher talked about, I just thought I'd share that with you, since I happen to have a piece in my home office. And again, it did not fly in space, the piece that I have here, but it is quite fascinating to look at. So with that, I want to go to a couple of questions that we had, and I think one came in particularly for Kristen, because it was engineering related. And let me see if I can re-find this question. Where did that question go? Looking, here it is. So Kristen, this question is for you. And the question is, what are some good classes to take in high school that will help me become an aerospace engineer?
Awesome. Yeah, that's a great question. So I definitely think physics is important, physics class, and then, some level of calculus. It doesn't have to be the most advanced calculus. I actually took calculus in high school and repeated the same one in college. Even though I could have test out of it or whatever, I didn't have to take the first Calc 1 or whatever it's called, because I wanted to make sure I really had that foundation. That's key, I think, with the math classes in particular. They all build on each other. And so, by the time I finished grad school, I was taking math courses that, those were hard. Some stuff that, I still have nightmares about. So making sure you really have that good foundation for math. So yeah, I would say calculus and physics. I happened to take like an electronics and robotics class. I had that offered in my high school. Not every high school might have that. That was really cool for me because I got a lot of kind of engineering experience because we didn't have an engineering class. If your high schools offer engineering type classes, that would be really neat. I also, as an elective, when I was a senior in high school, instead of taking early release, I actually I did wood shop. And so that was really fun for me. And that's actually been fun as an adult, being able to have some of those skills that I learned from back then to just, do hobbies and mess around. And that came in really handy once I started actually working with machinists and people who would actually build hardware. A lot of times we spend time building things in CAD, computer automated design, and then a machinist actually has to build your hardware based off of your drawings. And so having a little experience in the woodshop class was actually really useful for me. And then my high school didn't have a CAD class, but I know that's a lot more popular. So if you have an opportunity for studying CAD, whether it's a class or just playing with it, there's free open source software online. And 3D printing, I think also and this doesn't have to be high school. These could be college things you do in college too, but exposure to 3D printing, I feel like is huge. When I was in high school, that wasn't even a thing. People didn't know there wasn't 3D printing. So yeah, I hope that helps.
Awesome. And Kristen, I think you make a really good point of, trying these different things, because I know there was a question in the Q&A area that sort of asked about, what do you look for? What do you focus on for an internship? And I think Farnaz said it at best is, following your passion. And you mentioned that as well as Christopher as well. But also that idea of experiencing things you wouldn't perhaps ordinarily have experienced, whether that's wood shop or CAD printing or whatever it may be. You never know what's going to spark an interest in you until you get a little bit of experience with it. So don't close doors. Any opportunity to sort of try something that you're like, oh, I don't know anything about it, open those opportunities, and you never know what's going to happen.
Yep, absolutely.
Awesome. So Farnaz, I want to go to you with a question about, you talked about, some of the ups and downs and how you reached out to a professor to sort of get some help. And I wanted to see if you could talk a little bit more on, well, how do you find the courage to go reach out to a professor? What do you do? How do you do it? How do you find the courage? Can you talk a little bit to that and your experiences?
Yeah. So it was really hard for me as well. Back then I had heard about people, getting these opportunities with the professors, but I also had imposter syndrome. I felt like I lacked the courage. But yeah, I one day just kind of decided that I was going to do it. I was going to go for it. I would say patience. Don't expect like the first day of class that it's going to happen, that the professor is going to want to work with you. I would say research, read, kind of decide, okay, what is it that I like? And then, attend class and maybe try to connect with your professor first, see what they're doing, see what everybody else is doing, upperclassmen, see what's out there. And then, like you said, yeah, don't think like I have to do this type of research in this sort of field. Be open to all kinds of different opportunities. In my case, I took the first opportunity that came my way, which for me ended up being the perfect thing because I did microbiology and then ended up becoming a microbiologist. So yeah, I would say, yeah, just be open-minded, be patient, and don't let imposter syndrome get to you, or don't think like those people are better than you and you can't do it or you're not smart enough and all of that. I was actually a TA for microbiology, and I had students who would come up to me and they'd be like, yeah, I'm just not good at research. I'm not good at lab stuff. And I was like, look, and this is true. Like, I am not super like intelligent or good at math, or like, you know, like math and science is actually something that was hard for me. But the key in research, at least, is being consistent, because nobody's like counting how long it takes you to like, you know, calibrate this or use or learn how to use this machine. The key is just consistency, because even lots of very intelligent people lack that consistency and that sort of drive. So yeah, I don't know if that answered the question.
No, I think that was great. And you bring up that really good point for folks that, you know, don't compare yourself to others. You are you, and you are the best. Always aiming to be the best version of you can make you do wonders in your life in a positive way. And so, you know, focus on the uniqueness of you. And, you know, it makes me think of another question that we had in Slido, and that was about, you know, how do you help yourself stand out? We oftentimes hear cliche phrases, but can you talk? And and Christopher unfortunately had to drop off, so he's not available to answer some of our Q&A in this live session. But for Kristen and Farnaz, and I'll start with you, Kristen. Can you talk a little bit about what's the power of being different and unique? Is that a powerful thing? Do you have any recommendations on that, being unique and different?
Yeah, that's a great question. I think about kind of the folks that we've selected to be on our teams, and you know, passion for me, right? I think it depends kind of who's deciding. For me, passion is a big thing. You know, if you are coming to NASA, for instance, you have to want to be at NASA, right? We're generally intrinsically motivated here at NASA. It's an exciting group to be around. And so we want to surround ourselves by people who share that passion. So that won't necessarily make you unique. That'll make you like the rest of us in that you're passionate about NASA's mission and NASA's vision. But I do think it's, you know, when we read through proposals or applications, looking at some of the unique experiences that people have had, the diverse experiences that have kind of made them who they are, not necessarily in their education, right? Just in their life. I think when people are a little more vulnerable and share kind of their true stories of how they came to be, and it doesn't even have to be the most fascinating, right? We don't all have the most interesting stories of where we came from or how we got to where we are, but the people that are really honest and open, that stands out. So even when Farnaz was talking about, you know, some of the challenges that she had with depression and other things, that kind of openness, to me, those are the types of things when I see those in proposals and applications, that really sticks out with me. The people that are just kind of putting themselves out there.
Awesome. Thank you, Kristen. Farnaz, what do you have to add about either uniqueness or standing out or being different, and any power or usefulness of those things?
Yeah, I would say that some of your unique traits or even things that you find negative might end up being your strength. I realized that I'm a different type of learner. I hate lectures, and just generally, I didn't like taking classes in college at all. The only thing which is interesting, because I, you know, got to the master's level and I am hoping to do a PhD, but really what got me was the passion for the research. But I thought for a while that like I'm just kind of stupid or something. I don't know, because I just can't pay attention. It's not I don't like exams. It doesn't vibe with me. But I later found out that actually this unique style of learning, of looking at things, made me a good researcher. You know, I'm really good at tackling questions and looking at things from different perspectives, and may not be that great when it comes to, you know, taking a class or a lecture and taking exams, but it's really good when it comes to research. So yeah, I would say look at your differences in a different way. Because yeah, the people who have made breakthroughs were not the people who were just, you know, just like everybody else and this and that. Really see your differences as strengths.
And I think that's a really great point. Each and every one of you out there is unique, and the qualities that you do bring to the table are what make you stand out above the rest. And I love that Kristen mentioned also intrinsic motivation. And I think all of our speakers talked about the fact that if you love it, it will show. If you don't love what you're doing, it's not going to come across in the work you do, in the way you speak about the work you do, or in the way you may portray yourself in an interview. So be yourself, be unique, be hardworking. And I think all three of our speakers, Christopher, Farnaz, and Kristen, are great examples of you can be successful no matter what you thought in the beginning of, am I going to be able to do this or not? A quick question, Farnaz, how many years have you been working at the NASA Johnson Space Center with Jacobs?
About 3.5 years. I was an intern for 9 months, and then they hired me full time.
Awesome. And Kristen, how long have you been working at the Johnson Space Center?
9 years.
9 years.
Yep.
And so, and more opportunities are coming around for people who can be passionate about the work that they do. Well, it is about 14 minutes past the top of the hour. There are a couple of questions in Slido that we'll try to get answers to in Slido, so that will stay available, as will the poll. There's a poll there for you to be able to put in some input. And I want to thank all of you, Farnaz, Kristen, Christopher, as well as Selena and Margaret from the Texas Space Grant, or from the SEAS internship program, as well as Rosina and Suzanne, who have been working in the background to be able to help answer additional questions as well. We very much appreciate all of you. We will get an archive to Selena to send out to all of you as well. And thank you so much for participating. And we hope you've gained some valuable insight for your futures. Thanks, everyone.